Hey everybody, this is a video for my grade 10 introduction to applied and pre-calculus students. This is the first time that we are going to be starting off a unit that I didn't get a chance to hand out to you before school got shut down. So I am aware that there are some people who don't have a computer, or sorry, I shouldn't say that. I'm aware that there's some people who don't have a printer at their house, so printing out the pages for notes is going to be kind of difficult for them, if not impossible. Well, here's what I'm saying. For all of the stuff we're doing in notes here, a very quick sketch is fine. Please feel free to either slow down the video or pause it if you have to take the time to write this stuff out. And for these diagrams here, trust me, a rough sketch is really about all you need to get the point of what it is that I'm going to be doing here. So having said all that, let's dive into it. This unit's actually kind of short. We've already kind of talked about some of it in chapter 5. I think we can actually knock out pretty much two of the lessons per video here without making them too terribly long. So let's get started. We've talked about the rate of change back in chapter 5, and rate of change, of course, on a line is, remember, the change in the dependent over the change in the independent, what we called delta y over delta x, delta being the Greek letter, and we use it in math and science to mean change. And another way you can talk about this is with the words run and rise. Think about it. Rise means to go up and down, so that's my change in the y. And run means to go back and forth, and that is my change in the x. And think about it, rise, meaning going up, is positive, going down is negative, and since we read from left to right, math is no different, so running to the right is positive and running to the left is negative. So, looking at this line here, it goes from this point to this point as I go from left to right. So it's going in a positive direction because you start here and go to there, so that's a positive x direction. And it's going in a positive y direction. So its rise is, let me just erase that and start over for that. Its rise is positive. Its run is also positive. And a positive divided by a positive is, of course, a positive. Notice this line here, though. If I start at this point and go to that point, then my rise is actually going down. So that's a negative. Notice as I go from left to right, I'm still going in a positive direction because I'm going towards the right being positive on a grid. So that's a negative divided by a positive, which is negative. What's interesting is it wouldn't matter if I thought about going from this point to that point, because then I'd be thinking, well, I'm going from this point to this point. I'm going up, which is a positive rise, but I'm going to the left, which is a negative run. And a positive divided by negative is still a negative. So whether I think about this being the first point or this being the first point, as I move from one point to the other, my rise over run ratio has to be a negative. This one here is kind of hard to see. It didn't photocopy great, but this line goes from this point to that point. So it has a slope of 0 because, think about it, how much does it rise as you go from this dot to this dot? And the answer is 0. It doesn't get any higher from one point to the other. It still has a run, right? In this case, it runs 1, 2, 3, 4, 5, 6. It runs 6 units, which is positive, but it doesn't matter. 0 divided by any number, positive or negative, is 0. So a horizontal line is always going to have a slope of 0. What about vertical lines? Well, think about this. How much, as I go from this point to this point, does my graph rise? How much does it go up or down? Well, in this case, you could say, well, let's say we started here. Okay, it goes down 1, 2, 3, 4, 5, 6. There, it goes down 6. How much does it run, though, to get a change, a rate of change or a slope? Well, think about it. It doesn't run anywhere. It doesn't run forwards or backwards. It doesn't go left or right. So from this dot to this dot, the run is 0. Now over here, 0 divided by 6 is 0. But remember, one of the most key and unbreakable rules in all of math is that you can't divide by 0. So that is undefined. So you'd say a vertical line doesn't even have a slope. It's an undefined slope. A horizontal line is 0. As you go from left to right upwards, it's a positive slope, and as you go from left to right downwards, that's a negative slope. So that's the story on directions for slopes. Let's see if we can find some slopes here. We did this a little bit last unit, only we called it rate of change. But let's see. To go from E to F, what is the slope? Okay, let's see. Oh, one last thing before we leave this page I forgot. We used a letter in Chapter 5 to be our symbol for slope. Do you remember what it was? It was the letter M. So down here, when I'm going to say the slope, I want the slope M from 2 points, from point E to point F. So when I say M with a subscript EF, that means that I want the slope of this line from E to F. So let's see. It rises from -5 up to 4. So that's 5 units to get to the 0 and then 4 more units. So it rises 9. And it runs, let's see, it runs from -5 to 1 in terms of its horizontal distance. So it goes -5. So that's 5 units that way plus 1. So it's 9 over 5. Notice both of those numbers are positive because that was going up and to the right. Both of those are positive directions. So 9 over 5 is my slope. I don't want a decimal for slope almost ever. In the last unit, we had a few questions where rate of change made sense to put it in decimals because, I don't know, it was money. You don't usually say you have 9/5 of a dollar. But when we're dealing with just equations and algebra and geometry on a grid, 9 over 5 is a better way to say the slope than to use a decimal. So simplify it if you can. In this case, you can't. But leave it as a fraction. And no, I don't want mixed numbers either. Improper fractions, but simplified, are the best way to go. All right, on this one, I would like the slope from G to H. So I'm going to call G my starting point. I rise -1, -2, -3. And I run from -4 all the way to 2, 3, 4, 5, all the way to 5. So it takes 4 units to get to 0 and then 5 more units to get to H. So that's -3 over 9. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go again. It's a fraction, but this time, please notice the final answer should be simplified. 3/9 is the same as 1/3. Okay, so there's example 1. Example 2, what if I gave you a slope and I wanted you to draw me a line with that slope? Okay, it doesn't really matter where you start the line. It doesn't give you points to start with, so I'll just start at the origin. That's maybe the easiest place to start. And then I'm going to go 4 over 9. So I'm going to rise 4 and run 9. So I'm going to rise 4, which is there, and then go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So there we go. There is a line, and I probably should use a ruler for that, but good enough. There is a line with a slope of 4 over 9. It rises 4, it runs 9. And notice I could have put that line anywhere on here, right? I could have started over here. How about I start at -9, which means my run of 9 takes me to the y-axis and up to there. There we go. What do you notice about those two lines? Okay, keep that in mind. Oh, very nice. Norton's telling me something safe. Thanks, Norton. All right, now I got to make, these lines are positive. Now I got to make a negative line. How about I start at, since I got to rise 8, but I'm going negative, how about I start at 8? And then to go down 8, I think of this as a rise of -8, which means go down 8, and then run of +3. Notice, if I say rise is negative, run has to be positive, because I need this to be a negative number, and a negative divided by positive is negative. So I can go down 8 and over 3. There we go. Oh, I keep freezing. There we go. And I think this time I will use a ruler. Oh, I had a ruler. Where did it go? There it is. Doo-doo-doo. And this time I'll even draw it like this, right? I don't have to actually stop at those points. It did say actually draw a line. Technically, I made line segments there. The definition of the word line, if you want to be really fancy and technical in geometry, is that a line has to go forever. But there we go. That's a line that goes through those 2 points, and it has a rise of -8 and a run of 3. So its slope is -8 over 3. Please notice it would have been fine to start, say, at, how about I start here at -3, and I go up 8 and then go 3 to the left. So I could do a rise of positive 8 and a run of negative 3. And notice I'd get the exact same shaped line. So if I go 8 up and 1, 2, 3 to the left, notice I get another line that looks the same as my first line. And again, what do those two lines have in common, you think? And it's the same thing those two lines had in common. And yes, you're right, they're parallel. And just to make sure that this makes sense to you, negative 8 over 3 and 8 over negative 3, they're both the same number. And they both, you could write them as the negative of 8 over 3, right? If you think of fractions as divides especially, this is very easy, right? Negative 8 divided by 3 would be negative 2.6 repeating. 8 divided by negative 3 would be negative 2.6 repeating. And if I took 8, divided it by 3, and then slapped a negative in front, I'd get negative 2.6 repeating. They all equal the same thing. So it doesn't matter whether I put the negative on the rise or the run, as long as I only use it once. If I did a negative rise and a negative 1, my line would be positive, because a negative divided by a negative is positive. So keep that in mind. So that was example 2. And now let's move into formula. We talked about this last time. If I were to call the first point on this line that we count from x coordinate 1 and y coordinate 1, and the second point x coordinate 2 and y coordinate 2, the slope is y2 minus y1 over x2 minus x1. And that's a formula that we saw a little bit in chapter 5. Well, now formally, if you check out that formula sheet I gave you at the beginning of the course, that is on it. We will give you that formula for future tests involving this stuff. Okay, use the formula above to determine the slope of the following line. Okay, well, I have my choice here as to what x1 and y1 could be. I'm going to pick this point right here as going to be x1, y1. So that's going to be 0, negative 5. So that's my x1 and my y1. And I'll pick this point here, which looks like it's 5, 6, 7, 8, 8, comma, and ooh, I can't read these. These are so small. 5, 6, 8, 6 is my x2, y2. Perfect. So I'm going to use my formula. M is equal to y2 minus y1 over x2 minus x1. All right, so the second y coordinate is 6. The first y coordinate is 5. 6 minus negative 5. Be careful there. You got to know your integers. And then 8 minus 0. And that's going to be a slope of 11/8. What's cool about this is I should get exactly the same slope. Did I do this right? Hold on. That's not negative 5. Thank you. All right, there we go. That would have been an error for the ages. That's clearly not negative 5. Sorry, my eyes are having a hard time reading this tiny diagram. That's definitely negative 6. There we go. So that's 6 minus negative 6, which is 12 over 8. Oh, and that simplifies. 4 goes into those things, so that's 3 over 2. There we go. Please notice I could have picked any 2 points and I should get the same thing. In fact, I'm going to actually do that. So I'll just use my eraser. You could use a different color pen or something. Or actually, I could do that too. Let me use, here, I'll use a red. I'll call this, let's see, what is this point here? Let's count properly this time, eh? 1, 2, and minus 1, minus 2, minus 3. 2, negative 3, and that'll be my x1, y1. And then I'll pick this point here, which is 5, 6, I think that's 6, right? 1, 2, 3, 4, 5, 6, yep. 6, comma, 1, 2, 3, and that's my x2, y2. There we go. And now I'm going to find the slope of this line again. We already know from chapter 5 that the rate of change of a straight line should always be the same number no matter where you measure it. So the formula should spit out the same number again. Let's see if it does. All right, so y2 is 3 minus y1, which is negative 3, all over x2 is 6 minus x1 is 2. My apologies for how small this is. Boy, people watching this on a phone are going to really struggle. There, is that any better? My apologies. Anyway, 3 minus negative 3 is 6. 6 minus 2 is 4. And hey, does that look like that? Yeah, it does when I simplify it. And again, we already knew that. We knew from chapter 5 that the rate of change of a straight line has to be, or a linear relationship has to be a constant value. And that's true for slope as well. The slope of any 2 points on a line should always give me the same value. Cool. Example 4. Determine the slope of the line that passes through there. Okay, notice, finally, you people looking on a phone don't have to worry. No diagrams, just formula. So it's y2 minus y1 over x2 minus x1. Okay, let's make this x1 and y1 because they told it to me first, and we'll make this x2 and y2. So it's 6 minus negative 3 over 8 minus 4. And that's going to be 6 minus 3 is 9. 8 minus 4 is 4. And that fraction doesn't simplify, so it's 9/4. Okay? And did it matter that I called this one the first point and that one the second point? And the answer to that is no. Because think about it. If I had called this x1 and y1, and I'd have called this x2 and y2, notice that I would have got negative 3 minus 6 over 4 minus 8, which would be negative 9 over negative 4, which, what's a negative divided by a negative? Oh yeah, it's a positive. So it doesn't matter which point I call first and which point I call second, as long as, this is important, as long as if you decide that that's x coordinate 1, then its partner has to be y coordinate 1. Okay, if I decided that this was x coordinate 1, then its partner has to be y coordinate 1. You can't mix and match. Either this is the first point or it's the second point. Okay, how about we pause the video while I play with the focus feature here, and why don't you try be yourself. Try to be yourself. Try to do question be yourself. So pause it, give it a try, run it through the formula. Okay, did you try it? Did you get 4 minus 6 over 3 minus 1, which is negative 2 over 2, which is negative 1. Please don't leave negative 2 over 2 or negative 1 over 1. Give me a whole number for slope when you can. We do know that that has a denominator, right? It has the invisible denominator of 1. But if you're going to give me a whole integer, you can just tell it to me as a whole integer, please. Okay, is that how it worked out for you when you tried the formula? All right, now it wants us to actually graph these two things. Oh, sorry guys, back to graphs. So what do you think? Will these two lines look the same? Will they be parallel like these guys were? What do you think? Well, let's graph it and see. Okay, so E was 4, negative 3. So 4, negative 3. And then it was 8, 6. 8, 6. So this is E and F. And the next line was 1, 6, and 3, 4. So let's graph that. 1, 6, and 3, 4. Okay, 1, 6, and 3, 4. Well, were they parallel? No, they were not. Makes sense. One of the lines is going up. It's got a positive slope. And the other one's going down. It's a negative slope. So, and you know what? Once again, it did say that these are lines passing through the points. It didn't say they stopped at those points. So I should probably just keep them going here. So there we go. And yeah, they would in fact intersect someplace. Spoiler alert, later on in this chapter, we'll learn how to do things. Actually, in the next chapter, we'll learn how to do things like figure out exactly what the coordinates of that point is. And we won't have to graph it to do it. But anyway, that's in the future. There you go. Those two lines cross each other. Is there anything special about the way they cross each other? Do they meet at a right angle? Do those look like right angles? No. Anybody remember the word for two lines that cross at right angles? Remember it? Well, that sound familiar? The word is perpendicular. Two lines are parallel if they have the same slope. So if this is line 1 and this is line 2, M1 equals M2. Perpendicular lines have and this is where we get fancy, negative reciprocal slopes. What the heck does that mean? Well, if I have a slope for this one, it's M1 is the number for the slope, and this line has a slope, and I'll call it slope 2, then the slope of line 1 is equal to the negative reciprocal of the slope of line 2. Now, do you remember how to make a reciprocal? Quick flashback on that. What's the reciprocal of the number 2? 1/2, because remember 2 means 2 over 1. So to turn it into a reciprocal, you just flip the fraction over. What's the reciprocal of 2/3? 3/2. So if I had a line with a slope of 2, what would be the slope of the line that's perpendicular to it? It'd be negative 1/2. If I had a line with a slope of 2 over 3, it rose 2 for every 3 that it ran, right? Up 2 over 3, up 2 over 3. That's my line. What would the line look like of the line that hits it at a right angle? It would be negative 3/2. In other words, it would go down 3, down 3 over 2, down 3 over 2, and that would be the line. If you picked up this line and put it onto that line, they would cross at right angles. So, looking at example 1, and trying once again desperately to focus my camera. Oh, that's good. Okay, line ST passes through the points negative 2, 7. Let's draw that. Negative 2, 7. There we go. And 2, negative 5. 2 and negative 1, 2, 3, 4, 5. There we go. So that's ST. And I'm going to use a different color for UV. Oh, okay, I'm going to use pen. Don't mess it up, don't mess it up. Negative 2, 1, 2, 3, and 7, 6. Ooh, 7, 6. Okay, so 7, 1, 2, 3, 4, 5, 6. There we go. So this is U, negative 2, 3, and V, 7, 6, 7, 6. So that's this line. And again, it says that these are lines that pass through. They don't start and end there. They're lines that go on forever that pass through those 2 points. There we go. And the other one was, what was it again? S was the tall one, and T was the bottom one. And we have a line that goes through those. There we go. So, are these 2 lines parallel? No. Perpendicular? Maybe. I don't know. That looks kind of like a right angle. Let's see if I put a ruler right on it. Oh, where's my framing square from woodshop class? I don't know. Does that look like it's a perfectly right angle? I mean, I don't know. I could measure it. I could break out my protractor and measure it, and it could say it's 88 degrees, and maybe that's just because I drew the lines kind of fat. I can actually already see I didn't really hit this dot right in the middle, did I? So there's got to be a way to tell if it's perpendicular or neither algebraically, and there is. All we have to do is find the slope of line S to T and the slope of line U to V. So let's find those 2 things. Okay, so let's use our new formula. What's the formula again? Y2 minus Y1 over X2 minus X1. How did I remember that formula so quickly? Because I've used it a million times. You'll get it on a formula sheet, but once you've written it down a whole bunch of times, you'll just remember it. So I'm going to call this X2 and Y2. So it's going to be negative 5 minus 7 over 2 minus negative 2. Oops, 2 minus negative 2. Notice how I say that? Minus negative, and I just use the 2 negatives and turn them into a plus. I know, little tricks of the trade. So that's going to be negative 12 over 4, which is negative 3. All right. How about from U to V? I'll call this Y2, so 6 minus 3, over 7 minus negative 2. Watch, I'm going to do it again. 7 minus negative 2. Oh, sneaky. So 6 minus 3 is 3. 7 plus 2, spoiler alert, is 9. And that simplifies to 1/3. And what do I notice about those 2 numbers? If I took this number, which is really negative 3 over 1, right, and I flipped it over so that it's 1 over negative 3, and then took the negative of the negative, it would turn into this. So since MST is equal to the negative reciprocal of MUV, therefore ST is perpendicular to the line UV. And there is a symbol for perpendicular. Do you know what it is? It's an upside down capital T. Get it? It makes right angles. So that's the symbol for perpendicular if you want to add it to the notes up top. So there we go. Give you a sec to check that out. That's the kind of question you're going to have to do in the homework for this stuff. So that's example 1. Got like a couple more and then we'll turn you loose. Okay, example 2. Line AB passes through the point -4, -3, and B is 0, 3. So perpendicular, parallel, or neither? What do you think? Well, let's see. All right, sharpening my pencil here. So A is -4, -3. -4, -1, -2, -3. There's A. B is 0 over and 3 up. So there's A, there's B. Line. Oops, sorry, I'm way off the screen there. Line. I just don't want my line to be crooked. Beautiful. There's AB. And CD is 0, -3, so 0 over 3 down, and 4 over 3 up. 4 over and 1, 2, 3. Ooh, they're looking like they might be parallel. Now, don't just go concluding, yeah, they're parallel. They look parallel. Really? What if I drew them forever? I mean, even if they're off by being parallel by just even like a ½ a degree, eventually they'll cross into each other. So you know what? Even though my picture looks kind of parallel, definitely not perpendicular, I'm going to check. So what is the slope of AB? And what is the slope of CD? And we'll use our formula twice, and then we'll compare the two numbers. If they're not exactly the same, they're not really parallel, even though they pretty much look like it. So, want to pause and try the formula yourself? You back? All right. 3 minus -3, 3 minus -3, over 0 minus -4, 0 minus -4, is equal to 6 over 4, which simplifies to 3/2. CD is 3 minus -3 over 4 minus 0, which is 6 over 4, which is 3/2. Therefore, MAB is parallel to MCD. That's a D. Do you guys remember the symbol for parallel? That's the symbol for parallel. That's the symbol for therefore. That's the symbol for the letter M. Okay, we all understand our symbols. Next. Example 3. Draw a quadrilateral. Ooh, okay, this will be fun. With vertices 0, 4. Gotcha. That's A. B is 6, 6. 6, 6. That's B. C is 8, 3. 8 over 1, 2, 3. There's C. And D is 2, 1. 2, 1. D. So it's a quadrilateral, so I got to join all the points. Okay, I'm joining points. Joining points, joining points, joining points. Joining points. And okay, joining points. And I'm getting kind of sloppy in the way I'm drawing, even though I'm using a ruler. There we go. Okay. Is that a parallelogram? Well, looks like it might be a parallelogram. How would I know if it's a parallelogram? You know how I'd know? I would say ABCD is a parallelogram if, by the way, you're probably going, holy cow, this guy can't spell the word if. No, actually that means something in math and science. That actually means if and only if. So that's a special if. ABCD is a parallelogram if and only if the slope of AB is equal to the slope of BC, right? Those lines have to have the same slope. And the slope of AB. No! Sorry, I wrote that wrong. What I meant to say, backtrack, sorry. The slope of AB has to be the same as the slope of DC. Guys who were paying attention probably caught that mistake. And, I'm going to say and, the slope of AD has to equal, let's not mess this one up, the slope of BC. So that line and that line have to be parallel, and that line and that line have to be parallel. So let's find all these slopes. So the slope of AB, and again, if you want to pause the video and try to find the slopes for yourself, go ahead. But I'm going to go from A to B, which is 6 minus 4 over 6 minus 0, which is 2 over 6, which is 1/3. And the slope of D to C is going to be 1 minus 3 over 2 minus 8. And that equals -2 over -6, which the negatives cancel, is 1/3. So far, that's true. AB and DC are parallel. But you better check, are those two lines parallel? You can't just assume they are. We got to check it out. So I'm going to work over here. Sorry, I didn't give you a whole lot of room for this one. The slope from A to D. All right, from A to D, that's going to be, I'll make D the second point, so that's 1 minus 4 and 2 minus 0. That is -3/2. Makes sense. It's a downward line. It's got to have a negative slope. And then the slope from, I have to check for B to C. The slope from B to C. So B to C, that's 3 minus 6 over 8 minus 6. And let's see, what's 3 minus 6? That's a -3. What's 8 minus 6? That's a 2. And yep, same. Therefore, yep, that is definitely a quadrilateral. And that is definitely all that we're going to do as examples for 6.1 and 6.2. Check the blog. I basically assigned like a few questions from 6.1 and a few questions from 6.2, not a whole lot. Because, you know, again, this stuff is fairly quick. There's not a whole lot to it. You do have a test tomorrow, so if you'd rather leave the assignment until after tomorrow's test and work on it on Friday, I'm not posting anything new on Friday because Friday is a professional development day. It would have been an in-service and a day off for you had we had regular school. So if you want something to do on Friday, you can do it then. But basically try to have those questions for this lesson here done by Monday, and then we're still on pace. Thank you very much for watching, everybody, and good luck on tomorrow's test. I am live streaming this afternoon, and I have some office hours in Teams if you need to get a hold of me to ask me any last questions before you try your test tomorrow. See you later, guys.